Okay, lovelies, today we are going to talk about some exponent properties. This should be a review of stuff we've discussed already, but we're just going to review it before we do multiplying with polynomials. So the product property tells us that two values multiplied together, if the bases are the same, we add the exponents. So if my goal is to to create something that is equivalent to x to the power 5, that would be something like x to the power 3 times x squared. When we add those exponents, we get x to the power 5. Power to power property says that I'm going to multiply the exponents. So we could have x times x squared squared. This would give me x to the 4th. When I multiply these two together, 2 times 2 is 4, times another x would give me x to the power 5 again. Negative exponent says, help, I'm on the wrong side of the fraction. So if I had 1 over x to the negative 5th, that's the same as x to the positive 5th. Quotient property says I have more of the same, I'm going to subtract. As long as the bases are the same, I will subtract the exponents. So I want to have more on the top than the bottom, like x to the power of 10 over x to the power of 5. 10 minus 5 is 5, so this equals x to the power of 5. Zero exponent property says that anything to the power of 0 is 1. So if I did x to the 5th to the power of 0, that would be 1. So if I want it to simplify to x to the 5th, I would still have to multiply by x to the 5th, because anything to the power of 0 is 1. So that would be those examples. Then these are just actually applying these properties that we have, these rules, in the box and simplifying these the best we can. Negative 4 is a base. It's not a negative exponent, so it's just going to stay where it is. But this negative 5 exponent wants to come to the denominator so it can be positive. So negative 4 is left on top, and then we're going to have x to the positive 5 on the bottom, and that's as simple as that one gets. In this next example, the top is going to be 2s times 2s, because that's what squared means. 2 times 2 is 4. S times s is s squared. The numerator is still 6s to the 4th. We can divide both 4 and 6 by 2, which would give me 2 over 3. And then I have more s's in the denominator. When I subtract, I'm going to get 2 minus 4. That's that quotient rule, which would give me negative 2, or that tells me that the 2 s's are left over in the denominator, and that's our final answer there. This example, the u is being squared, but not the 3. So now we have 3u squared over 15, u to the 7th. Both 3 and 15 are divisible by 3, so we're going to go ahead and do that to simplify. There are more u's on the bottom, so when I subtract, I'll be left with 5, and they'll be left over in the denominator. So we end up with nothing but a 1 on top, and 5u to the power of 5 in the denominator. The other way to think about this, again, is if you have 2 u's on the top and 7 on the bottom, 2, 3, 4, 5, 6, 7. How many u's could you cancel out? 2, and we'd be left over with 5 in the denominator. Okay, in this next example, we need to distribute this 2 times that negative 4. So we have 12d to the 10th over 3d to the negative 8. These d's want to go up to the numerator so that they can be positive. 12 divided by 3 is 4. D to the 10th and plus the d to the 8 that we brought up. This is the product rule, and we add them. So now we have 4d to the 18 as our final answer. All right, this one looks scary, but again, we're just going to apply our properties. We're going to multiply for the power rule. So we get negative 3j to the positive 9. Negative times a negative is a positive. A to the negative 12, all over positive 3j to the 4th, a to the 8th. Oops, a to the 8th. Try again. A to the power of 8. Okay, these a's want to, oopsers, try what is a, okay. These a's want to come down to the denominator. We can divide 3 by 3 right here, and that gives us, it's negative 3 divided by 3, so that's negative 1 on the top. We're going to do j to the 9 minus 4, because that's the quotient rule. And we're going to have in the denominator a to the 8 and a to the positive 12, because the negative 12 comes down. When this simplifies, we're going to get negative j to the 5th over, now we're going to add these two exponents, power rule. 8 plus 12 is 20, so we get a to the 20th in the denominator here. All right, last but not least, we are going to distribute this exponent to both the 2 and the negative 2. So 10k to the 10th on the top. I've already lost what I was distributing. All right, so we get 2 to the power of negative 3 and k to the power of positive 6. These 2's want to come up, and we get 2 to the power of positive 3 times 10 times k to the 10 over k to the 6. We're going to subtract those exponents, but 2 times 2 times 2 is 8. So then we have 8 times 10 on the top, which is 80. We have k to the 10 over k to the 6, so we're going to subtract using our quotient rule, and we end up with 80 k to the 4th. And that's how we're going to apply these properties.